So if a car travels a total distance over various time intervals, you can determine how fast the car was traveling using the distance formula, D equals RT. What do you think D, R, and T represent? So D is probably the easiest. They almost tell it to us in the description. What's D? Distance. What's the obvious one? Yeah, time. T is time. So R is actually...
Please excuse this interruption. At this time, would any 9th, 10th, and 11th grader who wishes to have their pictures retaken, please report to the auditorium. At this time, any 9th, 10th, or 11th grader who wishes to have their pictures retaken, please report to the auditorium at this time.
Definitely didn't get my pictures taken.
They'll be able to go. They'll be... Yeah, I mean...
No, you don't.
Okay.
Since you have that chance taken, since you don't have that chance taken.
R is rate. It's actually not time, or range rather. R is rate. Think about if you are driving. You are driving a certain speed because there is a speed limit. That speed is your rate. How many miles did the car drive in the first 3 hours? So, how many miles did they drive in the first 3 hours? You go to time, 3. How many miles? What was the rate the car was traveling in the first 3 hours? So to find the rate, we need to solve D equals RT for R. So here's a literal equation. You need R by itself, so what are we going to do? Divide by T. So R equals D divided by T. So in the case of this problem, the distance was 204. The time was 3 hours. So you take 204 divided by 3. It's going to be something in the 60s. So their average speed was 68 miles per hour. Yes.
We don't have that time distance thing.
Oh, your little table.
Yeah.
Okay.
So I was confused how you got to.
I'm going to give my picture real quick.
Good luck. So 2-3 in our textbook is called rate of change and slope. Those words are literally interchangeable. Slope is the rate of change. The rate of change is slope. So if it asks you for either or, that's what we're finding. So, like I said, they are interchangeable. Slope is the ratio of change in the y to the corresponding change in the x. We learned it way back in the day as rise over run. But what I learned is that you never knew why it was called rise over run. Yeah, you kind of just draw and you know what it means. But rise over run came from the idea that the sun rose in the morning. So here's your rise. The sun is rising up. And as the sun is rising up, a person goes out, enjoys a run. So the sun rises up, the person runs horizontally. So that's where the idea of rise over run came from. The sun rising up and a person going for a run. Because you can't run into the sky. The slope of the line is the same as the rate of change. I told you that at the beginning. The title of this section is slope or rate of change. They mean the same. Rate of change, typically you'll hear the definition to be the change in a quantity over time. We know slope to be represented by the letter M. I honestly have no idea why it's the letter M. I've never found that out, but we know that slope is represented by the letter M of a line passing through 2 points. It's the ratio of the difference in the y's to the x's. So again, when you see your formula, it's M equals change in y over change in x. That's what the triangle symbol means. Change. We plug into y2 minus y1 over x2 minus x1. So again, we have a tendency to plug into y2 minus y1 over x2 minus x1. So example 1, a constant rate of change. The table shows the temperature of a solution after it's been removed from a heat source. Find the rate of change in temperature for the solution. So again, after 2 minutes, it appears to have cooled down from 143.6 to 139.4. After 5 minutes, it cooled to 133.1. So what we're going to do is we're going to find the rate of change for the temperature. So essentially what we are doing is finding the slope. So you can pick any 2 points. Maybe I want to pick 8 minutes and 2 minutes. Somebody else could have picked 5 and 0. So it does not matter. Everybody should be the same. So I picked 8 minutes, so the starting temperature is 126.8. That's your Y value. We're going to subtract from it the 139.4. And this corresponded to 8 minutes, so we're going to subtract from it 2 minutes. So the change in temperature is being divided by the change in time. Our time change was 6 minutes. Our temperature change was negative 12.6. So if I divide that by 6, I get negative 2.1. So what that means is the temperature is decreasing by 2.1 degrees Celsius per minute. So again, it means the temperature is decreasing by 2.1 degrees Celsius per minute. So putting your slope or your rate of change into words, understanding what is being asked. What was the temperature of the solution when it was removed from the heat? Where would I find that? What was the temperature of the solution when it was removed from the heat? What time would that occur? 0, right?
I was thinking about how the
At 0 minutes, that's the temperature it was the minute it was removed from the heat. That is the starting temperature before it decreased. Okay? After 30 baseball games, A-Rod had had 25 hits. If after 100 games he had had 80 hits, what is his average hits per game? So you take 100 hits minus 25 hits all over 80 games, 100 games, sorry. 80 hits for 100 games. Minus the first 30 games. So again, the 80 included that 25, so we have to take it away. So you had 55 hits. The 100 included the 30, so we take it away. So you have 70 games. So he's averaging 55 hits in 70 games, which is an average of 0.7857 hits per game, which means roughly 78.6% of the time he hits the ball in a game. Not per bat, per game. There's a difference. And who knows how old these stats are? Does even know your red is? Yeah. Our textbook is showing its age, and so nice. Here's the slope you like, right? Here's 2 points. Plug them into a formula. We love to plug and chug. So what's our formula? Remember our formula is m equals y2 minus y1 over x2 minus x1. When we look at points or ordered pairs, they are x comma y. So this is like your x1, y1. This is your x2, y2. It is important to keep the y2s and the y1s separate from the, x2s and x1s. You got to keep them grouped together. So if I make this my y2 and I plug that in first, then the 8 goes in x2 directly below it. So points have to sit stacked. So it's -6 minus 7 over 8 minus a -2. So -6 and -7 give you -13. A minus becomes a positive, so 8 plus 2 is 10. Guys, fractions are your friends. Keep them as a fraction. It is much easier to have slope as a fraction than a decimal. So I shouldn't hear any calculators right now.
Please excuse this interruption. At this time, would the following seniors please report to the auditorium to have their senior portrait taken? Andrea Diaz, James Dilly, Mariah Edwards, Madison King, Wyatt Machad, Brandon Myers, Jack Paver, Jake Pyatt, Mackenzie Price, Casey Sears, Will Smith, Heather Steganga, Weston Wiltrout, and Krista Cone. If there are any other seniors that wish to have a retake taken, please report to the auditorium now. Thank you.
Okay, 2 plus 2, because the minus, 4 plus 2, because the minus. So you get 4, 6. If you don't like 4, 6, because you know it reduces, you could rewrite it as 2/3. This one is especially one you don't want as a decimal. 2/3 is 0.6 repeating. 0.6 repeating would be a terrible slope. In letter C, you have -9 plus 3 over 7 minus 0. So you get -6/7. Good? Okay, these are some of my favorites. Find the slope of the line from the graph. Yesterday, we focused on identifying the x-intercepts and the y-intercepts. Those are the best points to pick for finding your slope. So right here, this -6, that is my x-intercept. It is the point where the graph crosses the x-axis. So my x-intercept is -6, 0. So that's 1 point on my graph. The y-intercept is 0, -3. That's where x equals 0, and the graph crosses the y-axis. So to find my slope, I'll use these 2 points. So y2 minus y1 over x2 minus x1. So you get +3 over -6 for a slope of -1/2. So what that means is going down 1 over 2, down 1 over 2. And if you follow along on your line, we can see that. Again, remember the negative tells me that my slope is decreasing. The line should be then going down. Is this line not going down? So you know if the line is going down, you better get a negative slope. Remember, the 1 is the rise or the run over the run, which is your 2. Good? Okay, your homework is on a handout.